Friends, today we are going to listen or we are going to discuss about the RSA algorithm, how to solve various issues in RSA algorithm using a fast exponent method. In the previous video lecture, we have actually discussed about what is RSA and how we are actually finding out the inverse of a public key. That is, if we are given with E and we are given with N, then how we are going to find what is the value of D and what is the value of phi n. We have seen this in our previous example. Those who have who doesn't know about these basic terminologies about what is a public key, what is a private key, what is the phi of n and what is n, then they should pause this video. There is a link in the upper side of this video. You can click that link and you can watch the video and come back to this video once you are done with the basic concepts. So those who are with us and those who have listened or viewed that video can carry further, we can move ahead with the fast exponent method. But before going into deep diving into the fast exponent method, let us quickly brush up our other concepts of RSA. So So let us continue with RSA algorithm. We have studied the algorithm. We will see once more when we go and discuss more about the fast exponent method. Let us consider that a user had to convert a set of characters II into the corresponding plain in ciphertext. So this is what it means. So okay. So what it says is I have this characters. I have this character II, right? This is the character that I'm talking about. I am talking about this II character, and I want to convert this II two times into this is my plain text. So this is my plain text. And I'm going to convert this into some ciphertext. Okay, I want to convert this into some ciphertext. This is the objective of our program. It says that I have a plain text and I want to convert that plain text into my ciphertext. Okay, now how we do in cryptography, because the thing is when we see this type of examples in simpler fashion, I have only the alphabets or characters. So what I will do, I will create one dictionary in which I have a sequence numbers. I have this sequence numbers here. Okay, I have this sequence number here like 0, 1 and everything, right? 0, 1, 2, 3, and corresponding to 0 I have a value called A, corresponding to 1 I have a value called B, corresponding to 2 I have a value called C, and likewise corresponding to 25 I have a value called Z. Okay, so I have all these values. So if we see in this table, if we go and check this table, then what is the value for I? What is the value for I? Okay, the value for I is 8, right? This is the value of I. So I can say that the value when I convert II into a digital format, I will get the value called 88, right? 2 times I means 2 times 88, 88. So the value in plain text now becomes, now the plain text will become 88, right? We will have this as a plain text. Okay, this is the plain text that we are going to use in our slides, in our execution of this code. Now coming to the basic of the algorithms. So what we have seen earlier is we have seen these steps. That is step number 1. That means in RSA we start with selecting two values P and Q, And the condition with P and Q is P should not be equal to Q and P and Q should be prime. Okay, this is the basic condition before we go for step number 1. We want to select two values P and Q. That means these two values are, suppose they are P 17 and Q is 11, and this value, this P and Q is they are private. We have seen in the last lecture these are private, private in a sense that only the sender and the receiver knows these two things, right? Now based on this P and Q, the second step is to calculate the value of n, whether the value of n can be calculated as P multiplied by Q. So the value of n will come up to be 17 multiplied by 11, that is 187, and this thing is public in nature. So public in nature means everybody in the world, if wants to access this, he can access the value of n. Okay. The third thing is we will find out the value of phi n. Phi n is actually the domain on which the multiplicative inverse of that value n lies, right? So that the value of phi n is P minus 1 and Q minus 1. So we will multiply these two and find the value as 160. If anybody doesn't understand what is phi n or how we get phi n, then he should or she should pause this video, go to the initial links that we have for the RSA algorithm, where we can explain why we get P minus 1, why we get Q minus 1 in the table now. So you will actually use this phi n value, right? So this is again a private data that is only visible to sender or the receiver. Finally, we will select a value of E, and the value of E has a condition, right? The value of E is the condition is the value of E lies between 1 and phi n, right? This is the first condition. This is the condition A. The condition B that belongs to this 4 is well, the GCD of E comma phi n should be 1. Okay, these are the two conditions that should be fulfilled before we select a value of E, that is the public key. So we have chosen a value of E for simplicity as 7 that has the value 1 for we have taken care of these two conditions, right? E lies between 1 and phi n. The phi n was 160. We have chosen E as one of the values. This condition is true, and when we see the GCD of phi n and E, it will be coming to 1 only. So we have to check. You can check GCD of phi n and n with the help of an Euclidean algorithm or a back substitution algorithm also. So if you get a 1, then or you can have your initial days of the schools, you know how to check the GCD of two numbers. You can check that. So in that, but division method also you can do. You can divide 7 by 187. No, 160. Whatever is the remainder here, so x is the remainder, the x becomes the dividend, like 7 comes in, and you do this do that particular thing. If you get a 0, this GCD, this x is the GCD now, and for this GCD, this for our case, this x should turn out to be 1. Okay, this is a division method that actually you have studied in your school, which tells you about how we find GCD of two numbers. Okay, so we can use any method to understand what is a GCD, right? But once you know what is, we should verify these two conditions. Okay, then only you can select a value called E. Now, once you are done with the value called E, what is else you need? You need a value called D. This is the private key. D is the private key of a cryptographic system, right? So this E is again a public. Okay, I forgot to mention this is public, that is known to all. Then D is calculated as E inverse mod of phi n. E was 7, so I need to have 7 inverse mod of 160. This is the value. So we need to calculate the value of D by using this particular equation, right? So the value of d now be calculated based on the back substitution method or the extended Euclidean algorithm method. So we can use any of the method. We have shown one method in our previous video, that is all about back substitution. In this we will not go into back substitution. We will tell you about quickly about the extended Euclidean algorithm. The extended Euclidean algorithm or EEA algorithm actually has a form like this mentioned. It has a column called Q. This is the quotient. It has a two value called R and R2, R1 and R2. This is the remainder. R is a remainder. T1, T2 are the static variables that you need to take care, and T is another variable. This is the C set of variables. These are three types of variables, and this is the value of, this is the domain value n, this is 160, this is 160, and then R2 is the number that you want to find. The inverse of the number that you need to find is the R2. Okay, so you need to, so this is R2. I hope you can see this R2, right? So R2 means that it has a value called 7, right? Now what we do is we will continue this particular thing. So you have 7 in the value of R2, 160 in R1. Then you need to have two things, right? You need to understand two things. One is that you will be using two values, 0 and 1, right? Initially these two values, these are the four values you should understand. This R1 will be the domain value, R2 will be the number for which you want to find the inverse, and T1 will always be 0 and T2 will always be 1. There is a mathematical proof for this. If somebody wants to and understand that mathematical proof, you can go and read about extended Euclidean algorithm, or if you want to like us to teach, you can contact us using the comment box or reach out to us using email. But understand now, so if you fill this table with this particular information, now what is, when you divide 160 by 2 by 7, you have a quotient called 22 and you have the remainder called 6, right? This is the two values that you fill once you divide 160 by 7. So you have a quotient called 22 and the remainder is 6. Based on these two values, now these two values 22 and 6, you are going to fill this T, because T has a condition. It says T1 minus Q times T2. T1 was 0, so T1 was 0 and Q was 22 and multiplied by 1, so you will get minus 22, right? This is the value you actually received here. So the next row, how it comes, it will shift this value in this R1, R is shifted to R2, T2 is shifted to T1 and the T is shifted to T2, right? This is how you actually get the second row. Now what you do the division of 6 and 7, okay? 7 divided by 6, so 6 1 is 6, so you will get a remainder called 1. Again you will update this T2 will be, now T1 value is 1, T1 value is 1 minus Q value is again 1 and T2 is minus 22, it is minus 22, so you get the value called 23. So this is the value you got in the T2, right? Now again what you do, you shift in the diagonal way. 6 comes into R1, 1 comes into R2, 22 minus 22 comes into T1 and 23 comes into T2, right? Again what you do, you divide 6 and 1, so 6 times 1 is 6, so you get the remainder called 0. Now again you calculate T, it will come out to be 160, right? Now again you do the shifting, you get 1, you get 0 here, you get 23 here and you get 160 here, right? So it says that whenever you receive a 1 in R1, right? The system says if you have this R1 as equal to 1, then it signifies that the GCD of 160 and 7, the GCD value of 160 and 7 is equal to 1. That means the inverse do exist. Inverse exists. Okay, and what is the inverse value? The corresponding column of T1 tells you the inverse value. So this is the inverse. So what is the inverse? The inverse of 7 is 23 in the domain of 160. Okay, this is the value. So you get the value of D as 23 using the same method, right? If you go back, if you have seen this extended equilibrium algorithm, in the last lecture we have actually seen this back propagation method, back substitution method, in which also again we have derived this. So you can read this. This is the algorithm. You can go through this video and you can pause it and you can solve it. But understand this thing here. Now if you see this equation here, it says that I have one term with 160, another term with 160, and the one mod 160. So it says if you have a number itself with the domain value, this term turns out to be 0, right? So you only have 7 mod 160 is equal to 1 mod 160, and your equation actually says 7 times something mod 160 should be 1. Okay, so 7 times what is 1? 23. So again the value of D from this is coming to be 23, right? So we have in both the cases, like back substitution or with the extended Euclidean algorithm, we have both the ways. We have seen that the value of D is coming to be 23. Okay, now coming to the fast exponent method. The fast exponent method, once you actually knows about the RSA, the cipher text can be calculated as cipher text means C is equal to P to the power E mod N, where E is a public key and N is the domain value. Likewise, you have, if you want to calculate, if you do a decipherment, then you have P calculated as C raised to the power D mod times N, where D is the private key and N is the domain value. So we will see both these things in this video, but remember these two equations. C is equal to P times mod of P times P raised to power E mod of N, and P is C raised to power D mod times N. Okay. Now coming to the fast exponent method, it says that we are given a data saying that the P value initially what we have chosen the value of P as 88, we have E as 7, and we have N as 187. Okay, and we know this thing that we know that the C, if we want to calculate the cipher text, we need to have P, E and N. Value of P was 88, E was 7, and mod N is there. So we will substitute all these values and we will get C is equal to 88 raised to power 7 mod times 187. So this is the equation that we are going to use. Now the step for fast exponent method says convert the exponent into binary. So in this equation I have 7 as the exponent, so I have to convert this 7 into its equivalent binary. So the binary value of 7 is 111. Then I have to write the base in the first column. So the base of this exponent is 88. So I have a base value that is 88, and I want to write this base value in the first column. Now let us go ahead and listen to we go and read all the steps, and then we will see the example. Then based on the second index, the index of the second column, we will decide two different formulas. The first formula says if the index of the second column is 0, you want to square the base and take a mod of n. You have to square the base and take the mod of n, right? This is what you need to do. This is what you need to do, right? But if the second column index is 1, you need to actually do this particular step, this is the step number 1, multiply the value that you got with the base itself, and then you calculate the mod. Okay, then you calculate the mod. This is what you need to do in the second case when you have a 1 in that column. So you need to remember these two formulas, for execution in the next step. Okay, so let us start with the execution. It says that again the values are same, the values remain the same. So we have step 1, we have an exponent called 7. We converted this 7 into the corresponding binary values, and we have 1, 1 and 1 in the 3 columns. This is the column 1, this is column 2, this is column 3, or you can say this is 0, 1 and 2 column. Okay, you have all these 3 columns in the step 2. Now what the step says, it says enter the base into the first column. So what was the base? Base was 88. Okay, now what we do, we put the base again directly into the first column, 88, right? Then we need to just check the index of the second column. It says check the index of the second column. So now the index of the second column is 1, and we know that if the index of the second column is 1, we have to use this formula instead of this formula, right? So we will do this and add it to the base, multiply it to base, again take a mod. This is what it means. So what is the base? Base was 88. You take the square of 88, mod it with 187. You will get a value here, some value say x. Then you multiply this x with 88, the base, and take a mod of 87. You will get a value called 44. You place this 44 in the column. So you will place 44 here. Okay. Now the next thing is again check what is the index of the second column. Now what you have to do, you have to take 44, square it is 44, mod of 187. This is the first thing you do. Then again you multiply whatever value you get with 88, the initial base. Not this is the intermediate value. You take this. This is the base of the system. This is called the base. You multiply it with 88, and then you take the mod with 187. So you will get a value called say 11. Okay, so this value comes out to be 11. Okay, let me show you here. So you got this. This is what we do. We take 80. The next time we take it 44. The next time we have taken it as 44 because this was 44, right? So this is with reference to this table. Now the table becomes this one. Okay, so for this one, this is the initial thing where starting off. So we take the starting variable 44. This is for the first thing that we do, and the base remains the same. Base is 88 only. So we will get 8 to 11. So this is the value of this value cell 11. So this is the last column. So this value that we got here is the cipher text. This is the cipher text. Okay. So for 88, the plain text 88 is converted into cipher text for 11. So we have converted, if it is a two-word system, like two-word system, then 11 stands for, what is the value of the system for 11, right? What is the value of the system for 11? Let's check here. 11 is L. So either if it is following 20 like this structure, then we have a value called L, right? So 88 I is converted into L. If you think 1 and 1 are two different entities, then you are having B and B, right? So either it will generate this as a cipher text, or it will generate L as a cipher text. So there can be two cipher texts for this conversion. But 88 cannot be there. So either what you will do, if I pass 88, you will take 88 mod of 26 and you will find a value, right? Then you can use it as a plain text. One is thing is this, you can do this way. Otherwise you take I and I and proceed in that way. You can do this. So this was the fast exponent method. Now what you need to do is you need to actually tell me what will be the value of, because I know the cipher text. Now I know the cipher text. Cipher text is 11. I know the value of D, that is 23. I know the value of N, that is 187. Okay. Now what you need to do is you need to calculate the plain text. Plain text is equal to cipher text raised to power D mod times N, that comes out to be 11 raised to power 23 mod of 187. So you need to tell me what is the value that I will get for this value, and how you will be doing it. So everybody just take up their pen and papers, try to solve this particular thing, and with showing me all the steps, that what is the value of P and how you get the P for that. Okay. So if you have any issues, you can comment it out, you can reach out to us, we will explain you the further process. Thank you very much.